Hello and welcome to Ganesh Institute. So, in today's video, we are going to discuss about matrix and its types. So, what all are we going to discuss? What is a matrix? Its array, like the geometrical representation. Then the types, for example, what is a null matrix? What is a symmetric matrix? Skew-symmetric matrix, upper triangular matrix, lower triangular matrix, and so on and so forth. Just for your kind information, this is going to be a part of series on linear algebra where we gradually increase the levels. So this is going to be an introductory session. Then later on, we'll go till linear transformation, vector spaces, subspaces, and thereafter we'll go to quadratic and connotation form. Okay. So just bear with us and let us know how do you find them. So what is a matrix? Matrix is basically an array, a rectangular array. So this is a structure to show with square closed brackets or parentheses. Let's say I'm writing some numbers here. So what you can see, these horizontal numbers, this arrangement is row, and the vertical one, these are columns, elements. Okay, every number, why I have written here 1 1 1 2 1 3, because it is represented as AMN. The element or member of a matrix is represented as AMN, where M represents the position of the row in which it lies and N represents the column. So if I'm writing A11, that means this element is in first row and first column. So what do you mean by first row? This is first row and this is first column. So what is the intersection point? This one, A11. Okay. Now, if we talk about the order of a matrix. So when we say AMN, this MN is the position of the element, right? Let's say I have written here 2, 3, 4, 5, 6, 7. How many rows are there? 2. How many columns are there? 3. So 2 cross 3 is the order, which brings us to 6. So 6 is the number of elements. So how do we write order? M cross N. Number of rows cross number of elements. Okay. Now, how many types of matrices are there? So if we talk about the types of matrices, so some of them are pretty much simpler as we can identify them based on the name. For example, if we talk about row matrix, so I think you can guess what it can be. So in row matrix, we have only the elements in a row and we have only one column. So we have 1, 2, 3. For example, in this example, we have 3 columns but only one row. So we can say that it is represented as row matrix because it has only one row and whichever number is there for columns. So the order of this is 1 by 3. So when you have only one row, it is a row matrix. Okay. What about column matrix? So in column matrix, what have we got is only one column. So can you see in this matrix, in this array, spelling of array is this, a geometrical representation. So basically column matrix has only one column. Can you see how many rows are there? 3. So the order is 3 cross 1. Okay. So this is about column matrix. When you have only one column and you can have as many number of rows as you want in your matrix. Then we have square matrix. What do you mean by square matrix? So as the name suggests, square. What do you mean by square? All the sides are equal. So if I'm having rows and columns, so number of rows have to be equal to number of columns. Okay. So how can we find out that particular matrix is a square matrix? See. How many rows? In this example, 2. How many columns? 2. So the order is 2 cross 2. So that's why we can say that this is a square matrix. What about this one? If I have written 2, 3, 4, 5, 6, 7. How many rows? 2. How many columns? 3. So order is 2 cross 3. So can you see? Can I see it as a rectangular matrix? Yes. Because number of rows are not equal to number of columns. Okay. Then comes diagonal matrix. So what do you mean by diagonal matrix? See. If we have any shape, let's say this rectangle, this is a diagonal, right? This is a diagonal. But the co-diagonal in diagonal matrix is this one. Okay. So what we will write here is, for example, I have elements in diagonal form and then rest all elements are 0. Then we can consider it as a diagonal matrix. Though the order will be 3 rows, 3 columns, that is 3 by 3. But because only diagonal is given and rest all the elements, diagonal elements are there, rest all elements are 0. So it is a diagonal matrix. Okay. We can have a scalar matrix as well. So when we say scalar matrix, what do you mean by scalar? Any numerical value having magnitude, right? So magnitude is the numerical value. So let's say I am writing 5a. Okay. Now 5 is a scalar value and a is a matrix. Now see, if I have a diagonal matrix, for example, 1, 1, 1. And if I multiply it by 5, so 5a will be 5, 5, 5, 0, 0, 0. So this is a scalar matrix multiplied by a scalar value. Okay. We can take out one value as common or we can multiply that value with the matrix and get the final matrix. Okay. Now what have we got? Just bear with me. So next type of matrix is unit or identity matrix. Very, very important. So when we say identity matrix, that means all the diagonal elements have to be 1 and rest all elements have to be 0. So this is an identity matrix of order 3. When I say identity matrix of order 2, all the diagonal elements have to be 1. So this is the 2 by 2 order matrix. This is 3 by 3 order of matrix. Okay. So both of them are unit or identity matrices. So the plural of matrix is matrices. Okay. Now what have we got? Null matrix. Null. What do you mean by null? No value, right? So null matrix can be considered as 0 matrix
in which we have all the elements as 0, be it a square matrix of 2 by 2 order or 3 by 3 order or a rectangular matrix. All the elements have to be 0, right? Then what have we got? Horizontal matrix. What can you say about horizontal matrix? So, of course, it is more inclined. You can see by the landscape that it is horizontally written. So, for example, all those rectangular matrices, for example, I'm writing 2 by 3 and 3 by 2. So, if I write 2 by 3, that means I have 2 rows and 3 columns, right? And if I write 3 by 2, that means I have 3 rows and 2 columns. What can you say? Is this a horizontal matrix or this one? Of course, this one, right? Why? Because number of rows are less here, and number of columns are more than rows. So that is a horizontal matrix, and this is a vertical matrix in which number of rows are more than number of columns. Okay? Then what have we got? So what have we got here is the next one. Just bear with me. So here it is submatrix. What do you mean by submatrix? See, if I have given you a particular matrix, this is a rectangular matrix of order 2 by 3, 2 rows, 3 columns. Can I make a matrix out of some of the elements out of this matrix, considering some of the elements from it? For example, 3, 5, 4, 2. So this has been brought out from the main matrix, correct? So this is called as submatrix of this main parent matrix. Okay. Then what have we got? Next type of matrix, which is very important, upper triangular matrix. Upper triangular matrix. Now, as the name suggests, see, I have written here some of the elements. Just consider the diagonal one. Okay. So in upper triangular matrix, what you do, only the elements which are present including diagonal and above it, upper triangular matrix. So this is a triangle. Can you see? This one is a triangle. I need these elements, rest all have to be 0. Okay. So I'm dividing a matrix using a diagonal. So this is an upper triangle and this one is a lower one. Okay. So if lower elements are 0, then it will be upper matrix, upper triangular. And if upper elements are 0 above the diagonal, okay, diagonal values, leading diagonal values, then, and these are not 0, all of them are not 0, then it is a lower triangular matrix. For example, tell me which one is upper triangular and which one is not. So you have this one, 4, 3, 1, 5, 5, 2, 7, Okay, 6, 3, rest these are 0. So can you see this is a leading diagonal and upper triangular has non-zero elements. Not all the entries are 0, whereas in lower value, lower than the leading diagonal, all values are 0. So it is an upper triangular matrix. Okay, upper triangular matrix. Whereas if I would have written it as this one, for example, 4, 3, 1, 5, this is my leading diagonal. I have considered all those elements above it 0. But can you see? This one is the leading diagonal. Upper elements are 0. So it is a lower triangular matrix. Lower triangular matrix. Okay. Now next one is transpose matrix. So what do we write in transpose matrix? Let me tell you. Let's say I have a matrix 1, 2, 3, 4. This is a 2 by 2 square matrix. If I need to find out the transpose, which is denoted by AT or A dash, then I need to interchange rows with columns. Okay, so this is the sign of interchange. So what I'll do, see, what is first row here? 1, 3. So A transpose will be, the row will become column. What is the second row? 2, 4, it will become second column. 2, 4. So when you convert rows into columns and column into rows, that is a transpose matrix. Okay. Then we have got symmetric matrix. Symmetric matrix. Symmetry. What do you mean by symmetry? When you see similar things, right? I mean, if you talk about as in layman terms, it is like similar. So when I have a particular matrix, let's say this is the one. Okay, now tell me its transpose. Row has to be converted into column. So 1, 2. Second row, second column. So can you see the matrix is equal to its transpose? When it is the case, then you say that it is a symmetric matrix. Okay. There is another term which is skew-symmetric. Skew-symmetric matrix. So in this, what we require is A has to be equal to minus A transpose. Okay. There must be minus value. So for example, I have this one matrix as 0 minus H minus G, H 0 minus F, G F 0. Tell me, what is its transpose? Yes. So its transpose will be first row has to be first column 0 minus H minus G. Second row has to be second column H 0 minus F. then third row has to be third column, GF0. Can you take minus common? What will you get? 0 minus H minus G, H0 minus F, and GF0. And this is A. So can I write it as minus A? So when matrix is equal to negative of its transpose, it is a skew-symmetric matrix. Okay? Rest of the topic we'll discuss in our next class.
Don't forget to like, share and subscribe our channel. Till our next video, take care of yourself. Bye-bye.